One of the easiest, most inexpensive ways to improve the overall quality of your beer is to make a yeast starter. Making a yeast starter means making more yeast. Pitching more yeast into the wort means that the yeast cells start healthy and stay healthy during fermentation. A large population of healthy yeast cells will ferment properly and give the finished beer the best possible appearance and flavor. A fermentation with too little yeast creates an unhealthy population of cells. Fermentation may be sluggish or incomplete, and the finished beer can have higher levels of byproducts like esters, phenols, diacetyl, or fusel alcohols that come across as unpleasant, sometimes overpowering flavors and aromas. Pitching more yeast also reduces the risk of microbial contamination of your wort, which is another major cause of overpowering, unpleasant taste. Pitching lots of healthy yeast is important for any fermentation, but it's especially critical when brewing strong beers and lagers, because the cells must cope with the added stress of greater osmotic pressure from high gravity wort, higher concentrations of alcohol, and cold temperatures. To increase both the amount and the overall health of the yeast you add to each batch of your beer, you could buy an extra smack pack or two of yeast and pitch them all. But a more efficient and cheaper way to achieve the same result, or better, is to make a yeast starter. A yeast starter is simply a tiny batch of wort brewed a day or so before the main batch to allow the cells to increase their population through reproduction and to give the cells a chance to adjust to life outside the smack pack or vial before you ask them to undertake the big job of turning gallons of wort into gallons of beer. By starting with 1 pack or 1 vial of liquid yeast and adding it to a little wort prepared with a few pennies worth of dry malt extract, you can end up with the same number of cells as if you had used 2, 3, or more smack packs. Let's go over the 4 things you will need to make a yeast starter. First, yeast to propagate. Second, a propagation vessel that you can sanitize and seal, 1 liter or larger. We strongly recommend borosilicate glass flasks because they're graduated by volume, heat tolerant, and resistant to thermal shock, so you can cool hot wort directly in the flask, and they're easy to seal with our third necessity, which is an airlock and rubber stopper to fit your propagation vessel, or a breathable foam stopper. Finally, dry malt extract. This will provide sugar and nutrients for our mini fermentation and simulate the environment the cells will encounter in the main batch. Any kind of pale-colored DME will do. Yeast starter kits are available from Northern Brewer and include everything you need except for the yeast. Now, let's make a starter. For our demonstration, we're going to make a 1500 milliliter starter in a 2000 milliliter flask with a breathable foam stopper using a YEAST smack pack. First, activate the yeast and allow it to incubate for at least a few hours. While the yeast incubates, we have a decision to make: how to boil the starter wort. The wort can be boiled directly in the flask, or it can be boiled in a saucepan, then poured into the flask. This minimizes the risk of boil over, it's a little safer, and it's the only option if you are using an electric stove. We are going to boil the wort for our starter in a saucepan and recommend you do the same. Later on, we'll show you how to boil it directly in the flask on a gas burner, should you so choose. Measure water. The same water you use for brewing is fine. We will collect 1500 milliliters. Mix the water with about 1 cup of dry malt extract in a large saucepan. Stir occasionally to help the DME dissolve, and bring it to a boil. When the starter wort has boiled for a few minutes, it's time to chill it. Use a funnel to carefully pour the wort into the flask. Use a heavy oven mitt to cover the flask tightly with a square of aluminum foil. Then use the oven mitt to move the flask to a cold water bath. A flask weight can help keep the flask submerged and allows you to use more water in the bath without letting the flask float or tip over. Swirl the flask occasionally and replace the water in the bath as needed to cool quickly. While this starter wort cools, let's go back and prepare an identical starter wort directly in the flask. First, measure the DME into the dry flask. Then fill it with the required amount of water. Swirl the flask to dissolve the DME as much as possible, then begin to heat it. As the wort heats up, swirl the flask a couple more times to finish dissolving the DME. Be sure to wear a heavy oven mitt and be very careful. Because of the flask's narrow neck, boil over can happen very quickly. Remember, do not boil in the flask if you are using an electric burner. Cover the flask with aluminum foil and chill in a cold water bath. Let's check in on our first starter wort. While the wort cools, sanitize the foam stopper, the yeast pack, and a pair of scissors. When the wort has cooled to pitching temperature, pitch the yeast and seal the flask with the sanitized foam stopper. Our starter preparation is now complete. In order for the yeast cells to propagate, the starter must incubate before we pitch it into the main batch. During incubation, the yeast cells from our smack pack will carry out a fermentation in miniature, part of which includes cell reproduction to increase the cell population, or cell count. Let's look at the 3 things the yeast cells need during incubation: time, temperature, and oxygen. First, time. Just like any fermentation, cells will need time to reproduce and ferment this wort. Incubation should be complete between 12 and 24 hours after pitching the yeast into the starter wort. Second, temperature. Because we're after lots of able, healthy yeast cells in a short amount of time, instead of optimal flavor, we will let this starter incubate at a fairly warm temperature to promote high cell metabolism and fast activity. Incubate the starter at warm room temperature, 70 to 75 Fahrenheit, even for lager yeast. Third, oxygen. Yeast cells require oxygen to reproduce, more oxygen than is left in boiled wort. A simple way to add oxygen to this small volume of liquid is to swirl the flask during incubation. Put the incubating starter in a place where you'll see it frequently to remind you to give it a swirl whenever you walk by. A gadgety alternative to manual aeration is a stir plate. Through constant agitation and a steady trickle of oxygen, a stir plate is the fastest and most efficient way to increase cell count and get the most out of a yeast starter. You may notice that our starter didn't look very active compared to the primary fermentation of a 5-gallon batch of beer. That is normal. While the starter is fermenting, the wort will look milky. When incubation is complete, you'll see a layer of white to tan-colored sediment on the bottom of the flask. That is our new, larger yeast population. This starter is ready to pitch. Incubation is complete, and our starter now contains billions and billions more cells than we started with. It's time to pitch it. Pitching is simple. Swirl the flask to dislodge the yeast at the bottom, and then pour the contents into the cooled wort in your primary fermenter. Alternatively, you may wish to decant most of the spent starter wort and add mostly yeast to your main batch. To do this, chill the flask for several hours to thoroughly settle out the yeast. Then carefully pour the spent wort off the top. Leave just enough wort in the flask to get the settled yeast back into suspension so it can be poured into the main batch. For high-gravity beers, or for 10-gallon batches, you may wish to increase the cell count even more with a 2-step propagation. To do this, prepare and incubate a starter, then decant the spent wort. That's the first propagation step. The second step is to add another equal volume of boiled, cooled starter wort to the yeast slurry in the decanted flask and repeat the steps for incubation. Let's go over the tangible differences yeast starters will make in your beer. Lower incidence of off flavors from bacterial or wild yeast contamination, cleaner flavor and aroma with lower levels of esters, phenols, and other fermentation byproducts. Primary fermentation will typically start faster and finish sooner, and the beer will tend to finish more dry and crisp, with less chance of a sickly sweet finish from under attenuation or a stuck fermentation. Arguably the best place to start in your quest for the perfect homebrewed beer is with your yeast. Listen to your beer, as homebrewing grandmaster Fred Eckhart says, it's asking for happy yeast. Happy yeast equals good beer, which equals happy homebrewers. Incubate on, incubators.